All right, how are you doing, students? Algebra 2 students of Mendez High School. We are going over lesson 3.18 today. Today is Wednesday, the 15th, and lesson 3.18 says the quadratic formula and complex solutions. Our learning targets for today is I can find complex solutions to quadratic equations by using the quadratic formula. So we know we are using the quadratic formula. If you're not familiar with the quadratic formula, you have not been doing the lessons from Monday, Tuesday. So the quadratic formula, I'll go over that also. And they're talking about complex solutions. And we know that complex solutions are basically solutions where you have a complex number. So A plus BI. So these are the type of solutions we're going to be working on with these problems. All right, let's get started with the warm-up. Okay, so the warm-up for this problem, let me move that out the way. The warm-up says mentally, meaning in your mind without any help of any calculator or any writing or anything like that, just in your head, in your mind, decide whether the solutions to each equation are real numbers or not. So you have these four equations here. Decide which ones are real solutions. Which ones have real numbers solutions and which ones do not. Go ahead and do that now. All right, so now that you had a chance to determine which one of these have real solutions or real numbers as solutions and which ones do not, we're gonna go over these. So here are the answers. The first one here has non-real solutions. The second one has non-real solutions. The third one has real solutions, and the fourth one has non-real solutions. So if you selected the first two and last one, you got it correct. So now I'm going to go over why these have non-real solutions and why this one here is the only one that has a real solution. So the way I'm going to work it out is like this. Okay, so we have w squared is equal to negative 367. If I wanted to solve for w, I would have to get rid of this squared. And how do I get rid of a square? I take the square root of both sides. Now, the square and the square root cancel out. I'm left with w equals. We know that whenever you take the square root of a number, you always have a plus or a minus answer. Because we have a negative inside of the square root, I automatically know I'm going to have I. And I don't know what the square root of 367 is, so I'm just going to leave it as square root of 367. This I automatically makes this equation have non-real solutions. Okay, so the second example, we have to work this one out a little bit more than the first one. So this one says x squared plus 25 is equal to 0. In order for us to be able to solve this, I need to isolate the x squared. So I'm going to move the 25 with a negative 25 to both sides. These 25s subtract. We are left with x squared is equal to 0 minus 25 is negative 25. And same situation as this. If I take the square root of both sides, this square root and this square cancel, I'm left with plus or minus. Now, because it has a negative inside of the square root, that would be I. And then, oh, and we know what square root of 5 is, 25. The square root of 25 is 5. So actually, I went ahead of myself. And I put this here. So our answer or our solution for this problem is going to be the square root of 25 is 5. And since it has a negative inside the square root, it'll be 5i. Now, because we have the I in our solution, that is a non-real solution. Okay, the third one, the one that we already know is a real solution. So we have our equation, y plus 5 squared equals to 0. Well, same situation. Since I have the squared isolated already, I can take the square root of both sides. The square root and the square cancel, or they eliminate. We get y plus 5 is equal to square root of 0 is, technically it's plus or minus 0. And then we subtract 5 to both sides. And then we get y is equal to negative 5. Now, this does not have an I, therefore it is a real solution. Okay, and then finally, the last one here, we have the same situation. I'm gonna just work it out from here. So in order for us to be able to solve this, I already have my squared isolated. So I can just take the square root of both sides. The square and the square root cancel. Z plus 5 is equal to plus or minus, and you can see that there's a negative inside the square root, so that automatically will give us I. Square root of 367, and similar situation as the first one, because there's an I, it is a non-real solution. Okay, so from now on, you should be able to look at these very simple quadratics and in your head be able to determine if they have a real solution or a non-real solution. All right, the first activity that you guys are gonna work on says, Kiran was using the quadratic formula to solve the equation x squared minus 12x plus 41 equals 0. He wrote this, and they're using the quadratic formula, so x is equal to 12 plus or minus square root of 144 minus 164, all divided by 2. And now it says, then he noticed that the number inside the square root is negative and said, this equation does not have any solutions. All right, so based off of what we just talked about in the warm-up and what you guys have learned, you're gonna answer this question first. Do you agree with Kiran? Explain your reasoning. So do you agree with Kiran, yes or no? Go ahead and put your answer now. All right, so now that you guys had a chance to put your answer, let's go ahead and go over it. So do we agree with Kiran or not? And if you wrote, or if you said the equation doesn't have any real solutions, but it will have non-real solutions, then you are correct. So basically, because when we subtract 144 minus 164, when we subtract this here, so 144 minus 164, we end up getting square root of negative 20. And we have learned that when we take the square root of a negative number, we're going to get our imaginary number I, and that automatically gives it a non-real solution. So from now on, you're not going to say this does not have solutions. You can't say that no more. What you're going to say is it does not have real solutions, but it does have non-real solutions, which makes them complex solutions. Okay, so now you're going to get the opportunity to write the square root of negative 20 as an imaginary number. I kind of did it already here for you, but I want you to try to break this down and simplify it as best as you can. Go ahead and put your answer now. All right, awesome. So now that you guys had opportunity to try and answer this question on your own, let's go ahead and do that. Well, I already kind of gave you a hint that this will become I square root of 20, but what I was asking you to do is break down this 20 using a factor tree, finding all our prime factors. So what gives us 20? We know that 4 times 5 is 20, and we know that 2 times 2 times 5 will give us 20. Since we have a pair of 2's, the square root of 4 is basically 2, so this will become 2i, and then since the 5 cannot be broken down anymore and doesn't have a pair, it will stay inside the square root, so that would become 2i square root of 5. And that's what I want to make sure you guys continue with. You're going to be needing this in the future. Okay, so that's what it would break down to. And now step number 3 says solve the equation 3x squared minus 10x plus 50 is equal to 0 and plot the solutions in the complex plane. So you guys are going to take a couple of minutes to solve this problem. I'm going to give you guys a hint. Here is the quadratic formula with blanks for our terms. You're going to plug them in and work it out and try to find the solution on your own. Go ahead and take a couple of minutes and do that, and then tell us what you got. Go ahead and do that now. All right, cool. So let's go over to see if you got it right. This one's a little bit complicated, but it's okay. One thing that I want to make sure you guys always notice is that our equation is equal to 0. When your equation is equal to 0, the first term with the x squared is the a, the term with the regular x with no squared is your b, and the term without an x is your c. The quadratic formula says x equals negative b, so we have a negative 10 in here, plus or minus square root of negative 10 squared minus 4ac. So a is 3 and c is 50. All divided by 2 times a, which is 3 in this case. So here we go. So we end up getting a negative times a negative equals a positive 10, plus or minus the square root, this is kind of hard, negative 10 squared means negative 10 times negative 10, so that's 100. And then minus 4 times 3 times 50. So 4 times 3 times 50 gives us 600, so minus 600. All over 2 times 3 is 6. Okay, so now we continue. So we have, that's a 10. I know it's not that pretty. So we get 10 plus or minus the square root of 100 minus 600 is equal to negative 500 all over 6. And now, because they're asking us to graph our solutions, I'm not going to worry about breaking down the square root like I broke down this square root of 20 over here. I'm not going to do that because they want us to graph. So what I'm going to do is I'm going to actually take the square root of 500, and we're going to be using decimals. So in this case, we get x is equal to 10 plus or minus. Now, because there's a negative inside the square root, we know we're going to have a complex answer, which will give us the imaginary number I. Square root of 500 is 22 point, and I'm just going to round this up to 0.4 I all over 6. Okay, so at this point, because we have a plus or minus solution, we're going to have our two solutions. So the first one's going to say x is equal to 10 plus 22.4i divided by 6. And then our next one's going to say x is equal to 10 minus 22i square root of 6. Now, the only way we're going to be able to graph this is if we divide. Now, since we're dividing this 10 plus 22.4 I, we have to divide the 10 by the 6 and the 22.4 by the 6. So if I were to divide 10 divided by 6, I would get 1.7. So 1.7 and then plus, and 22.4 divided by 6 is going to give us 3.7. So that becomes 3.7i. When we solve this side, it will be the exact same thing, but instead of a plus, it'll be a minus. So we'll get 1.7 minus 3.7i. So now we have to graph these. So my first x-intercept will be 1.7 plus 3.7i. And my second one is 1.7 minus 3.7i. And we have learned how to graph complex numbers. So 1.7 on the real becomes 1.7 is about right here. 3.7i positive means we're going to go up. So 1, 2, 3.7 will be about right there. So that's our first point. Okay. And then we're going to graph this point, which is 1.7 minus. So we're going to go 1.7 right here. And then minus 3.79. So negative 1, negative 2, negative 3.7i is about right here. And that's it. So they wanted us to plot the solutions in the complex plane. We plotted those solutions. That would be that point there, and that would be that point there. Okay? All right. So the next thing that they want us to do is they want us to solve these 3 problems here. Now, if we were at school, your teacher would probably have you do this. For each row, you and your partner will each solve a quadratic equation. You should each get the same answer. If you disagree, work to reach an agreement. Now, we are not at school. You are doing this solo in your house. So you're going to try these on your own. So you're going to go ahead and try to solve the first one. I'm going to go ahead and give you whichever method you want to use. You can either use quadratic formula, or you guys should have learned completing the square yesterday. Go ahead and try to solve this one on your own. Then I'll go over it right now. Go ahead and do that now. All right. So now that you guys had a chance to solve this problem here, I'm going to go ahead and solve it with you. If you already know how to solve this, that's awesome. If you don't know how to solve this yet, please make sure you pay attention. So the quadratic formula is x equals negative b. So we have a negative, and b in this case is negative 4, plus or minus the square root of, and just in case you guys are wondering why I'm writing like this, it's really hard to write with the mouse. But here we go, I'm doing my best. So negative 4 squared minus 4 times a times C. So in this case, A is an invisible 1, and C would be this -4. So I'm going to put a -4 right here. All divided by 2 times A, which in this case is 1. So now we continue. A negative times a negative is a positive, so I get +4 plus or minus square root of -4 times a -4 is 16. -4 times 1 is -4 times -4 is +16. All over 2 times 1 is 2. So I get x is equal to 4 plus or minus square root of 32, because 16 plus 16 is 32, all over 2. Okay, you think we're done here, but we're not. In this situation, we do want to simplify the square root of 32. So square root of 32 is going to simplify as 16 times 2. Now, if we were to break down this square root of 32 as the square root of 16 times the square root of 2, that breaks down as square root of 16 times square root of 2, and we know square root of 16 is 4, and we can't take the square root of 2, so we just leave that as 2. That's just another way of working out the factor tree. So now this becomes x is equal to 4 plus or minus 4 square root of 2 all over 2. And the beautiful thing here is that 4 and 4 can be divided by 2. So my answers are 2 plus or minus 2 square root of 2. And it's no longer over anything because 2 got divided out by these 4s. Now, you can separate our answers as x is equal to 2 plus 2 square root of 2. And you can get it also as 2 minus 2 square root of 2. Now, you should know that these are not imaginary because they don't have i's. We did not have a negative inside the square root. So in this case, you would say these are two real solutions. And the reason why they're real solutions is because you did not take the square root of a negative. All right, cool. If you did not get that as your answer, hopefully you now understand how to solve this quadratic equation with the quadratic formula. Okay, so now you're going to go ahead and try to solve the second one on your own. This is just more practice. Go ahead and do that now. Okay, so now that you guys had a chance to work this out on your own, this one you should automatically remember from the warm-up that because it has a square, we can just go ahead and start working this out by eliminating that square. That's the beautiful thing about this problem. If you actually expanded this, if you did y minus 2 times y minus 2, and then you multiplied out here with FOIL or the box method, and you worked it like that, that's also awesome. You could totally do it like that. But why are you making your life so complicated? All you have to do here is take the square root of both sides. This square and this square root cancel. We're left with y minus 2 is equal to, well, I can break down this square root of 8. So -8 broken down can become -1 times 4 times 2, right? 4 times 2 is 8, and times -1 is -8. So here, because we have a -1, that's going to be I. The square root of 4 is 2, and since there's an extra 2, I'm going to get 2i square root of 2. So this becomes 2i square root of 2. Now let's continue. Since I have this y minus 2 over here, I want to get rid of this by adding 2 to both sides. Those 2 subtract become 0. We're left with y is equal to, since this 2 has an I and a square root, and this 2 doesn't, all I'm going to get is 2. Oh, I forgot to put the plus or minus. So this would be plus or minus. My fault. Plus or minus right there. So I get 2 plus or minus 2i square root of 2. Now, it looks like this one. It looks like this problem, but it's different. And the reason why it's different is because it has the I. So are these real solutions? The answer is no. In this case, when we split this, we get y is equal to 2 plus 2i square root of 2. And then we also get y is equal to 2 minus 2i square root of 2. And since they both have i's in their answer, you would say these are two, you can say non-real, or you can also say complex. These are two complex solutions I'm a shorthand solutions as so. You can also say two non-real solutions, or you can even say two imaginary solutions. All of those are totally cool for you to say. Two complex solutions, two non-real solutions, two imaginary solutions. But because in the warm-up they asked for non-real and real, we're going to go ahead and say two non-real solutions. All right, cool. So the next problem that you're going to work out is this one here. Go ahead and try to see if you can figure this out. Take a couple of minutes to work it out. Go ahead and do that now. All right, awesome. So now that you guys had a chance to work this out, hopefully you guys got it correct. Now, some of you might be thinking of taking the square root of both sides, kind of like we did here. You're not able to do that because this t squared is not alone as it was in this format. Here you have a minus 20t. So unfortunately, you're going to have to make this equal to 0 because if it's not equal to 0, you can't use the quadratic formula. So how do I move a minus 25? I move a minus 25 by adding 25 to both sides. Once I add 25 to both sides, those cancel out. You get 4t squared minus 20t plus 25 is equal to 0. And now that it's equal to 0, now I can go ahead and use the quadratic formula. So I say x is equal to negative b, in this case is negative 20. Remember, this is a, this is b, and this is c. Plus or minus the square root of b squared, so negative 20 squared. We're going to have really big numbers. I hope you guys have calculators. Times 4. A in this case is 4, and c in this case is 25. All over 2 times 4. Okay, let's continue. So now we work it out. A negative times a negative is a positive, so I get 20 plus or minus square root of negative 20 squared means negative 20 times negative 20, and negative 20 times negative 20 is 400. Minus 4 times 4 is 16 times 25, that's equal to 400. All over 2 times 4 is 8. Okay, so x is equal to 20 plus or minus the square root of 400 minus 400 is 0. That's crazy. Okay, and can we take the square root of 0? Yes, we can. The square root of 0 is just 0. So then we're left with 20 over 8. Now, why didn't I put plus or minus 0? Well, I didn't put plus or minus 0 because plus or minus 0 is just 0. So I'm not going to leave it there. So what you got to do now is you have to, I'm going to go ahead and simplify this. Since I see a 20 and I see an 8, I know I can divide both the numerator and denominator by 4. So I would get 5 over 2. And if you wanted to be fancy and divide that, you're going to get 2.5. So in this case, is this answer imaginary? And the answer to that is no. It's not imaginary because we don't have I. Now, is it a real solution? The answer is yes. But how many real solutions is this? In this situation, you have one real solution. Okay, in this case, because we had an answer where one was a positive and one was a negative, that was two real. In this case, we had a positive and a negative, two solutions. So these were two non-real because they have the imaginary number I. And in this case, because the numbers inside of the square root became 0, we're only left with one, technically one solution, and that'll be one real solution because it's not an imaginary solution. Okay, so I hope you guys understood what we did here in these examples. The next thing you got to do is not go do your code down. I messed up again. So now go back to Schoology and you're going to look for the assignment called Practice Lesson 3.18. These are just more practice problems of quadratic formulas. You have to do this before you do the code down. Once you finish this practice, go ahead and go back to Schoology and work on the code down. All right? And thank you, and you guys are all awesome. Good luck. You guys do have a test coming up on Monday, and Friday there's going to be a lot of practice, so make sure you guys get this done so that you know how to do this work. you have any questions, as always, please contact your teachers, and hopefully you guys are all staying safe. Good luck. And believe it or not, the teachers, we really miss you guys. All right, take care. Talk to you guys later. Bye.